In the middle of a crowded Delhi courtyard, there stands a single column of iron. It looks ordinary at first glance. Walk closer and it becomes impossible to ignore. It is pitted and weathered, but almost entirely unrusted. It has stood through centuries of monsoons, city fires, and empires, and it barely bears the orange stains that normally eat iron. How can a piece of iron, made long before modern steel, refuse to rot away? That question has pulled in historians, engineers, and curious travelers for more than a century. This is the story of the iron pillar, not a myth, not a legend, but a real, physical object that challenges what we think ancient metalworking could do. The pillar is tall and thin. It's not a statue. It's a column of wrought iron, hammered and joined to reach its final form. It stands alone on a stone base, surrounded now by ruins and tourists. The metal is massive. The pillar likely weighed several tons when it was put up. An old inscription on the pillar praises a great king and tells us it was raised in honor of a ruler. That short text gives historians a clue about when it was made. But the real mystery isn't who ordered it. It's how those blacksmiths made iron that could survive weather for centuries without corroding the way normal iron does. To understand why this is strange, think about most iron left outside. It flakes, it turns orange and brown, and it slowly crumbles. Rust is how iron returns to the earth. It's a chemical process, and it happens to almost everything we leave exposed. Yet this pillar, made by furnace and hammer, looks almost as if it refuses to join that fate. For a long time, people suggested miracles. Some said the metal had a special divine blessing. Others quietly suggested advanced lost knowledge. Scientists investigated, and the answers turned out to be more fascinating than magical. Close study of the pillar's metal shows it is not a crude lump of ore. It's high-quality wrought iron, refined by skillful hands. The iron has very low levels of sulfur and manganese, chemicals that make iron weak and prone to decay. But more importantly, it contains an unusually high level of phosphorus. High phosphorus in iron sounds like a bad thing. In later iron making, phosphorus makes metal brittle. But in this pillar, phosphorus appears to be the key to a natural protective layer. When iron corrodes, it first forms loose rust. In most iron, that rust flakes away and leaves more metal to attack. But in some cases, a thin, stable layer forms on the surface and protects the metal underneath. Scientists have identified that the pillar's surface is covered with a thin film containing iron oxyhydroxides and compounds rich in phosphorus. This film, a kind of natural varnish, is unusual. It forms slowly in the presence of oxygen and moisture, but it needs special ingredients to become stable and protective, ingredients found in the pillar. Metallurgists examining samples discovered microscopic particles of slag embedded in the iron. These remnants tell an important story. They show the pillar was made by joining smaller pieces of iron together. Ancient smiths used a process called forge welding. They heated, hammered, and welded iron blooms into larger sections. Then they hammered the sections together, creating a long, seamless-looking column. Forge welding is simple to describe but hard to do well. It requires controlling heat, working quickly, and understanding the behavior of the metal. The pillar's makers did this at a scale that still surprises modern blacksmiths. If you compare this with modern consumer iron, the difference is clear. The pillar's iron is dense and worked. The slag inclusions and phosphorus levels are consistent with ore smelting techniques used in that region. Ancient smiths may have intentionally left some phosphorus in the metal because it was impossible to remove with their furnaces. But instead of being a flaw, the phosphorus helped create the protective surface that exists today. Environmental factors also helped the pillar survive. Delhi's air, the local soil chemistry, and limited industrial pollution in earlier centuries all contributed to the slow formation of that protective film. Clean air means fewer pollutants that can break down protective layers. A calm environment allowed the film to harden and adhere to the metal, so we have a mix of good metal, clever forging, and favorable environment. But the story gets richer. Scientists analyzing the pillar's skin with modern instruments found a specific iron compound in the surface layer. This compound, a form of iron oxyhydroxide, is rare in typical rust. It is more stable and much less porous. It's so effective that it stops oxygen and water from reaching fresh iron below. This particular compound is encouraged to form when phosphorus is present. The phosphorus interacts with iron and oxygen to produce a compact protective film. In lab tests, researchers reproduced similar films by using phosphorus-rich iron and exposing it to controlled humidity. The films that formed looked remarkably like the pillar's skin, but even with lab tests, some questions remain. Did the pillar's makers know that a phosphorus-rich bloom would protect the metal centuries later? Or was it an accidental benefit of their available ore and techniques? That is where history and archaeology meet science. We know ancient ironworkers in the region used ores that naturally contained phosphorus. Their furnaces did not reach the temperatures needed to burn phosphorus out, so their iron retained higher phosphorus than later, cleaner steelmaking. They were skilled at folding and forging iron, getting large, nearly seamless shapes from smaller pieces. They polished and hammered the surface, which also helped the protective film adhere. None of this proves intent. It does, however, show a remarkable convergence of material, technique, and time. Whether accidental or deliberate, the result was a column that could survive the elements in a way few ancient metals did. Archaeology adds another layer. The pillar originally stood in a different location and may have been moved. The inscription helps date it roughly to a time of great artistic and scientific achievement in the region. That era produced fine temple art, precise astronomical instruments carved in stone, and advanced urban planning. Skilled metalworking fits into that broader picture. Here's a surprising fact. The iron in the pillar is purer than many modern-day wrought irons. The blacksmiths achieved a density and work that very few later artifacts show. For historians, that raises questions about craft traditions, apprenticeships, secret recipes, and techniques passed through generations. In the 20th and 21st centuries, several researchers tried to replicate the pillar. They used ancient-style furnaces and local ores. In some experiments, they created iron with similar phosphorus levels. When exposed to cyclic humidity, some of their samples developed protective layers too. These experiments don't recreate the pillar exactly, but they show the phenomenon is reproducible with the right materials and methods. That brings us to the moment when the mystery feels less like magic and more like human genius. The ironworkers of that time understood their materials in a practical way. They may not have written down a modern scientific explanation, but they knew which ores produced strong metal and how to hammer and join it. The pillar is a physical record of those skills. Still, the pillar keeps a few secrets. We don't know the complete chain of its manufacture. We don't know whether the decision to leave phosphorus was conscious. We don't know the exact furnace designs used by the artisans who forged and welded each section. And those unknowns are part of the wonder. Standing beside the pillar, you feel the gap between now and then. You can touch cold metal that has endured beyond empires. You can look up at a slender shaft and imagine hammers ringing, charcoal fires burning, and hands shaping iron with patient force. The iron pillar is not proof of supernatural skill. It is proof of human skill that we are still learning to appreciate. It reminds us that ancient technology can be surprising, elegant, and effective. So the next time you see rust on a bicycle or a bridge, remember this pillar in Delhi. It is a patient lesson about materials, environment, and craft. It tells us that sometimes ancient people, working without modern theory, produced results that challenge our expectations. The pillar still raises questions. Why did those blacksmiths choose those ores? How did they manage the heat and joints so well? Could those methods help us design new, more sustainable ways to protect metal today? We may not have all the answers, but the pillar gives us something else. It gives us astonishment. It shows that the past holds practical knowledge shaped by trial, skill, and intuition, and maybe that is the greatest part of the mystery. Not that the iron refused to rust, but that it proves people long ago could combine simple materials and steady hands to create something that would outlast them. What would you do if you could visit that courtyard and touch history for a moment? Imagine the sound of the hammer. Imagine the heat of the forge. Imagine a world where a simple column of iron could carry a message across centuries. That message still stands today. Human hands can do things that seem impossible when we first look. The pillar keeps guarding its secret, but piece by piece, method by method, we are learning how it was made. And every new discovery only deepens the mystery and our admiration for the people who made it. Thanks for watching. If this kind of mystery fascinates you, there are many more forgotten technologies waiting to be explored. Subscribe and join the next journey into the past.